Oh, okay. So let's start working further on our container or whatever this is. Yeah. So let's first test what we were doing. So we have a simple. We can now print this. We can concatenate this. We can store data. That is good enough for me, and I don't have any direction. Oh yeah, I have direction. So we can. The next thing is to expand the size and copy constructions to do. Let's build a to do and copy constructor deep copy constructor deep copy. And another thing is expansion, manual expansion and automatic expansion. Manual expansion and automatic expansion. So we will do this one by one. So copy constructor, let's build a copy constructor. Let's do manual expansion first. Yeah, so let's make a member function void expand we can concatenate what we need to expand with this some size. Okay, so we will accept a size t essentially. Expansion size, it's as simple as that. Okay, and we will at the end we will add a stream insert, but we can't add a stream insert because we don't have an out. Okay, but yeah, never mind. But yes, we can just this is a simple thing to do, I guess. So for expansion we will make a new array. I don't know what I'm doing, but let's make a new array of value type value type new arr. So this is expansion size, and so we have the m size also. So for this we will allocate some memory in there, remove this, and we will make a new value type of size t, the expansion size plus the we can also call this now. Wait a second. Okay, so expansion size plus the m size, already existing m size, and what we will do is also do the stream insert, and we have the we can manually call the function and provide it out now. So cout std cout, what's wrong with that? There's something wrong with that. We can just provide that. Works for me actually. So you can also call the virtual function. Yes, I guess, I don't know, but we will try. So let's because I have no IntelliSense for some reasons, we will build the file. Okay, this is working. So we can assign some memory to a new array, and we will simply copy the copy for the size. Basically we will copy this to the new array itself, the old array to the new array. So we will just run a simple function for its indexes. We will run this. New array is m items or let's also call it items for consistency. Put this here. Yes, is it items? No. Yep. So for m items at I, so this will loop, this will do its thing, which will copy the data to the new array, and we will do some memory pointer address exchange, which is crazy shit. Okay, so to do this, I don't even know what I'm doing, but yeah, so we will first this thing is we will do the stream insert at the end, and okay, move this here. We have created the new array, and m items, now we can delete the m items manually, which is crazy, and we have deleted the m items, and we will assign m items to m item address of new items. The address will be assigned m items is equal to address of new items. This is a pointer. What is this? This is also a pointer, na? So we just need to do this. So we have assigned memory and some assigned memory, and we can increase the m size, m capacity equal to m, or we can just do plus equal to the expansion size. So should we just go to main.stream and call it for the container one and expand this for let's say by 5. It is surprisingly working. Everything is surprisingly working. Wait a second. So we are printing 2 times. First time we are printing here, second time we are printing here, and yeah, that works. So the capacity is increased, size is the same, content is this. So we are actually okay, because we are pointing it here. Let's see if the code is even working or not. I am just so amazed by the code being working. Yep, the code dumped because we are trying to print the deleted address memory from some deleted address, which is not mine. This is working crazy. Okay, instead of the stream insert, we can just manually count this and ask for new capacity updated. M capacity is the new updated capacity because we are calling this function. See, capacity updated to 35. So we can expand this now, and we can also do some checks at concatenation. So okay, so this is okay. Let's see another thing. So this is a heavy operation. So if we print, if someone tries to expand, see, so if m capacity is equal to m size, then we will return the function and we will print that. Sorry, if it's not equal to something like this, so we can't expand it manually. So manual expansion is strict. We can't expand it for no reason, because it just does not make sense to expand if this is not equal to m size for manual expansion. Opacity is greater than current size, and we will print and we will abort this. Expansion aborted. Cool. And now if we run this, and we don't want to run this heavy operation for no reason, so see, this works. And if I print this container now, oh, I'm not trying to build this, I'm just trying to print this, my bad. Yeah, the size is same, so expansion aborted, size is same. This is fire, bro. I love this. So we are concatenating things, it's Pavan, size is 6, so it is working. And we know manual expansion now, but we need dynamic expansion, so we can simply go to concatenation and remove the code, not remove the code, but yes. So while doing this, what we will do is use a static int default FAULT default expansion size. We will go here and write int container default expansion size to, let's say, 5, or let's say 10. So the expansion size will be 10 always. Okay, so for making the expansion size thing work, we will check if okay. Before doing this, let's understand what I did here at the expand thing, this thing. So we have to work around with this, and I will just copy this, let's say print this essentially, and paste to Escalidra. See, so let's expand this also. So this is the code. What we are doing here is first building a new array and assigning it new memory. So while assigning it new memory, now we are using the provided expansion size and the already existing m size. Cool. And then when dynamically the new memory is allocated, when dynamic memory allocation, what we're doing is running a simple for loop. The simple for loop is just copying the old items to the new items and leaving everything else empty, and we are deleting the memory or freeing the memory of the old items because we have already copied it to something else. And because the best thing is these are pointers, both of these are pointers, hence we can simply change the addresses. So we can point the address of this m items, we can point the address of new items to m items. I guess we can also delete, if you can understand what I'm doing, we can also delete new items because we don't need the memory and it's just leaking it. Essentially we are just essentially leaking the memory here. No, sorry, we will never need this after it is assigned, the address is assigned. Or is it? No, we can't do this, we can never do this because we are assigning the address. So the two pointers are pointing to the same memory, so we can't remove that memory. Okay, so understanding it here with an example. So memory m items and new items. What we are essentially doing with these two is, see, this was pointing to some memory location, which can be accessed by where Rishi is stored, or let's say some memory location which is something 0x01, and we can do the same for this. Let's reduce the size. This is still pointing to some memory location which is empty. What we are doing is copying this here. Okay, wait a second. So this is also addressing to some memory which we just created at that time. At this line we created a new memory here, which is larger than the contiguous memory. The contiguous memory is certainly larger than this one because we are adding something in the memory size. And then the best part is we can एक मिनट. So what we're talking is the memory we assigned, new memory we assigned, we just copied the items of this into this, but the memory locations are still there because this is initialized to some junk value initially. After that we removed this memory or deleted this memory. We deleted this memory. Like this. Now we don't have this memory essentially, and because this is pointing to a null pointer, it's not pointing to null pointer, it's just pointing to memory which is deleted, but we are redirecting the pointer to point here. So there are two pointers which are pointing to the same memory, but see, this is the beauty of memory locations. Cool. So this code is simple, and we then we are checking if the m size is not equal to the m capacity, so that we don't do such heavy operations of allocating new memory with the some expansion size. So let's say I manually come and give 900 more memory locations or expansion size when not needed. So we are checking if we actually need the memory or the user actually needs the memory, and if not, we are returning we are printing to the console that you don't need the memory. So this is getting one step back. It's it's more efficient. So the next step would be this was manual memory allocation, but we would like to do automatic memory allocation or automatic expansion. So for automatic expansion, we can go here. We have to build some kind of logic to check the check for the new size or whatever this is. So we will check if the appended array size, or let's just not remove this, appended array size is n. Yeah, so obviously the size of the appended array is n, and if n is greater than, or the memory we need is greater than the capacity minus the items, or not the items, minus the size, which means the available memory is greater than n, we will expand it by a static variable which we already defined, which is default expansion size, which is essentially 10. Cool. So okay, so for our debugging purpose, this should not be there, but let's do some debugging, kind of debugging, and we will assume, we will write in the console that expanded capacity by 10 by the default expansion size, and then we will append this to concatenate. So if something is here, if it is not there, we will expand this, but this will not work all the time. I will explain how. So let's see. So if I just go in my container and reduce the default capacity to 10, and now if I build it again, run it again, let's see what we see here. So first line is building the container. We build the container and printed that. So it contains Rishi with size 6 and capacity 30. Okay, why is the capacity 30? For some reason, I don't know. What the fuck? Okay, because we manually asked to okay, never mind. So we not even need to change the default capacity anywhere, because we are just initializing it with less capacity. So let's see what's happening here. We will reduce the expansion here. We will just print the concatenation here. Just see, let's see. So let's build this and print this out. Expanded capacity by 10. See, we expanded the capacity by 10. This is crazy. So the logic is working very well. Let's not do this check and not expand the capacity automatically, and now let's see what will happen if we try to do something like this. This is still working, but the issue is if the capacity is greater than the size and content is still working, this essentially means the memory we are pointing to is not ours, and it is operating system's memory, which is not a good thing, essentially. Which is not a good thing to do something like this, which because this is operating system's memory and this is not secure at any point of time. See, so what we need to do is check that and expand the capacity. So expansion aborted. What? Am I manually expanded? What the hell just happened? Okay, let's not do anything. Yeah, so it's printing the size. Cool. It's concatenating it and then printing the size. Okay, so we are clashing with code of the manual expansion and the check. So while we are checking the check succeeds because there is not enough capacity in which with respect to what we ordered. uh, we are using this function to expand the capacity and expanding it by default expansion size. So we are printing expanded capacity by 10 and then printed this line, but we are also aborting the expansion for some reason because current capacity is something like this. Okay, so we are still not expanding it, but okay, so I guess we for currently we don't want this code. Okay, so the best thing to change is not this. So this should not be this. This should be greater than, just simple greater than. So if capacity is greater than m size, don't do this. But still it won't work because yeah, so it still won't work. Let's we will do this. We will make this work. See, capacity updated to 20, expanded capacity by 10, and the new capacity is 20 now. But the issue would be if I add a very long string which is greater than the default expansion capacity. So a b c d e f g h I j, something like this. So this is certainly greater than the so let's run this. Let's try to run this. See, the content is here, the size is 33, the capacity is 20. So the issue is while concatenating it will expand at a point, but it will not expand enough. It will not expand enough. Cool. So we need to run a loop for this to work. So instead of this sorry, not this one, not this snippet, where is that snippet? This, here it is. So we will run the expand capacity. We will expand the capacity until we don't hit this. While this we will expand it. We will just expand this. We don't need anything. We don't even need this to print. We will just update the capacity here and there. Okay, see, it is updating the capacity. It is updating the capacity. So updated capacity, capacity updated 20, capacity updated 30, capacity updated 40, and now the capacity is 40, size is 33, and we have the content. And now we can concatenate two strings together. Let's do this multiple times and let's see what happens. I don't know what, just I didn't never saved this, sorry. Malloc corrupted top size. Okay, so this happens because of a lot of okay, there is some issues, but we will try to fix them. Let's see. Core dumped, corrupted top size. How can you corrupt a top size? Essentially we top the size of an array we can create. Okay, but see, it is working essentially. So let's do this only. Pavan, can we do now? Capacity updated 20. Cool. If we do this multiple times, see, this works. The capacity updated to 30 and the size is still 30. Cool. If we do this again, save this, run this, capacity updated 40, size 36. So our the code is working. It is automatically expanded the capacity, which is cool AF, I would say. And this works, but this will not work for very long arrays. This will abort the core. We will have to fix that. So fixes. So the core abortion. See, so we'll try to fix it sometime, but we are done with copy constructors, not copy constructor, but manual expansion. We also need to implement a copy constructor so that we can do that also. And for manual expansion, I guess it is good to do manual expansion. Not good, but this is a heavy operation to assign a lot of memory. But never mind. Who cares actually? Okay. This will abort the memory every time we try to do something like this. We will figure that out also in long run. But see, this is automatically expanding capacities when we want to.